Welcome back to BAS 121. We're on Chapter 12, Data Mining, and we're looking at a couple classification techniques. So our last video took us through K nearest neighbor. Now let's go up here, and I've taken that same data set, the modified credit approval, and I've portioned the data based on set up a training set and a validation set. And now let's classify it using a discriminant analysis. Now what a discriminant analysis is going to do is it's going to give us a basically two equations, one for success and one for failure. It's going to calculate a score based on those linear equations for each one. In whichever score is the highest, that's how it's going to determine the approved or disapproved for us. So once again, we're going to do very similar stuff. There's our input data. There's our decision variable. And again, we want binary yes or no decision, 1 and 5. 1 is success and 50%. Next, we can use equal probabilities. Now this gets into how critical it is if we make a mistake. So we can say we can classify them with equal probabilities, or we can weight them in case that making a wrong decision one way or the other is very critical. Now in this case, we probably want to use equal weights, but in some cases where, let's say I'm deciding whether someone should have government clearance or not, I might not want to have equal probabilities. But in this case, let's use equal probabilities. And let's get our summary report. And here you can see we've done some discriminant values. We've defined success. Now what this is this, let me slide it down a little bit more for you. This gives us our equation for a success and our equation for failure. So here's our constant, and there's the slope of our homers, just like we did when we did multiple regression. There's our equation. So we'd run all the data through this equation, and then we'd run it through this one, and whichever one has the highest score, we would determine it's a 1 or a 0. You can see this. We had, in our training set, we didn't have any misclassifications. In our validation set, we had 3, so about 15%. And it told us, so not a bad model. We could go up and we could do the same thing here. Get the step 2 and score new data. We come up here to our credit decisions, and we want to score this data down here, the new data that came into our set. The models match, and we'll say OK and finish. Now we can say the new scores, and notice we could compare these two. Probably the same folks are getting approved versus not approved, but there's where they classified them. 1 is approved, 2 is not approved. Let's go back to the navigator. There you can see the validation scores, the inputs, and there you see the two equations. So the book walks you through if we actually calculated one of these and one of these, which it already does for us right here. It tells us whether they were approved or not approved, and their probability of success. So that's using discriminant analysis for the various ways. The last way we could do it is we could come up here and we could say logistic regression. We want to get back to our correct data partitioning. Again, we'd pull over all our variables. In this case, we do have the option to put some weights on, but let's just run it the way it is. I don't want to force the term to 0. I do want to set a confidence interval of 95%. Can hit next. I'm going to go ahead and do our in worksheet, and let's score some based on our regression analysis, or our logistic regression. Where's our data range? Down here. Match. And here we could see, notice logistic regression gives us the same type of information, same prediction of those data sets. So if we wanted to, we could go through and actually calculate each one of the compare each one of them under each one of the classification techniques. I think we'd get pretty much the same answer. But there we went through discriminant, logistic regression very quickly, and K nearest neighbor. 3 examples of classification techniques, how to come up with classifications to use to predict the outcome of new data.